One of the big concerns with levees is if the river rises to the point where it's spilling out of its river channel and rising up against the levees, that water level is now higher than the ground level on the other side, and the water pressure will begin to force water underneath the levee. And if it was just pure water that was moving through and seeping to the surface, that would not really be a great concern. But if that water starts to move through fast enough to carry particles of sediment and begin to open up channels underneath the levee, if those got to be very large, there's the potential for the levee to actually collapse into that space, and we can have then a wall of water that's passing through that gap in a levee failure. So some of the work that we've been doing, taking advantage of the 2011 event when water levels were right up against the levees, and we were beginning to form some of those passages underneath the levee and making sand boils at the toe of the levee. We went and sampled water from the levees and from relief wells that are designed to take some of that pressure off, and from the river itself, thinking that there might be a difference in the geochemical signal between water that was traveling, say, right underneath the levees, which would be more of a concern, and water that might be traveling very deep, which would be less of a concern. And we did in fact see differences in the water chemistry based on those two different pathways. One of the things that people who are responsible for levee safety are looking for when the water rises up against the levees are the presence of those sand boils that tell them that sediment is actually being channeled from underneath the levee. But it would definitely be useful for, as you mentioned, for identifying critical points to pay attention to, areas along the levee that would be lower risk and higher risk, even though they're both forming sand boils. This particular case, it's also just an intriguing problem that it was a privilege to be part of an investigation where we could come up with an idea that said it might be possible to be able to identify these shallow and deep pathways just by looking at the chemical signature of the water that's coming out of the ground, to be able to go out, take the samples, run them, get the results back, and find that in fact that is what turned out to be true.